Carson from Textile, and I'm going to talk about a talk I've given similar variants to before that focuses on just different models for dealing with and better taking advantage of and using user data. Like I said, I've done a bunch of different variants of this talk, and usually I focus on kind of things from the perspective of the user, so like things like privacy, autonomy, control, security, encryption, and it's super relevant to like a lot of the things that Textile as a team builds. That's a sort of driving force and a lot of the motivation for what we do. And usually the super short version of that talk goes something like, personal data on the web, what could possibly go wrong? And then, we find out that most of the time, nothing, right? The internet just works. We've got servers, we've got clients. Most of us are here because the internet actually does work, so everything's great. And then things go wrong. We get sort of misuse of data. Users' data maybe gets misused. We shouldn't really be surprised, though, because the relationship that users have with the platforms that they're using, especially in a sort of Web 2 world, isn't fixed. And so a successful platform can basically flip their relationship with users to be more extractive than creative. And then users become the product. And that's pretty much the spiel I give, and it's like, oh yeah, that's how we're going to get them. We're going to convince them that privacy is important, that they should be concerned about their data. But the thing is A, I'm talking to a bunch of developers and designers and biz dev people today, and B, your users probably don't actually care about these issues like we do. And this graph kind of suggests, but this is 2018 was when sort of Cambridge Analytica happened, and actually interest in privacy is waning. It's not actually going up, which is surprising. So maybe we're not going to sell people on different technologies and things like that by trying to scare them. Maybe we need to actually focus on some of the benefits of actually building on top of sort of more decentralized technologies. And so one of the things that a lot of sort of traditional app development companies and people talk about is this idea of network effects. And you might have heard Anderson Horowitz, Alex Ramble talk about this, Matt Turk talk about this. Everybody talks about network effects. You got to have those network effects, or no one's going to give you millions of dollars to build your next big startup idea. And if you're not familiar with network effects, basically the idea is the more data you collect about your users, the better product you can give your users, which allows you to get more users, to collect more data about those users, to develop a better product, et cetera, et cetera. And it's this nice feedback loop. And traditional sort of walled garden type applications get built this way. And so we end up with a bunch of really valuable data constrained into a single app or service with really a limited view of the people that they're actually interacting with. So we get data that's siloed behind an app. There's a very limited perspective on what that person as a digital being looks like. But hey, we've got network effects and we have all the control, so that's great. We can just keep onboarding more users and then sell their data to the highest bidder. And so we end up with this as a sort of pretty lazy model that pretty much is just going to sell advertising to people instead of being creative about how you monetize a business that you're building. Something that's a sort of ethos of Web 3 technology. So instead, imagine something a bit more like this, where we actually drive app development and app structures using Web 3 ideals, where we've got decentralized control, network impacts instead of network effects, and that's kind of what I want to talk about today, and then this idea of user siloed data rather than app siloed data. And all of this kind of leads to a broader view of what users are actually doing. So I'm going to start with these middle two, and just imagine for a second that we could change this sort of tired Web 2 way of doing things. And imagine instead all of your users come to your application with their data, right? So you haven't onboarded them yet, but they've installed your dApp, and they come to you, and they've already got some data bootstrapped for you. And now it's your job to do something really awesome for them with that data. And then, because we've learned our lesson with Web 2 technologies, we're going to make sure that we encrypt and encode and are careful about how we handle that data. So imagine a world in which we can already do that. What might that look like? And maybe it would look something kind of like this, if everybody remembers Winamp skins way back in the day. Basically, it's the same app, Winamp, playing music for you. Maybe you downloaded that with Napster or something like that at the time. And everybody had their own version of Winamp, but it was the same thing. And it was the same underlying data probably as well. And so you started to see this sort of idea that the app is really just an interface or a view on top of the underlying structured data. So we basically had these pluggable, hackable views of the same app, but provided a really highly customized user experience. So what about if we built a web that looked a little bit like that? What would we need for that? Well, we'd need an interoperable data format of some kind, like the MP3 of the internet, for all the digital data. And so this is something our team has been thinking a lot about, and we call this idea user siloed data. So instead of app siloed data, user siloed data. Data is tied to a user, where essentially the user's content preferences in one app can actually augment or inform the experience in another app. So essentially this idea that each app is really just a view on the underlying data. In fact, that's what it is, right? And that's what a computer engineer is really doing. We're just moving data around and making it look different in different contexts. That's what an app is effectively doing, right? So then what you can get is, imagine you just have 1,000 Twitters or 1,000,000 Twitters. Everybody has their own Twitter interface. And if you want, chronological order, hey, you should get chronological order. If you want something else, you should get something else. Or even something simpler than that, if all of your apps knew that you preferred dark mode before you even onboarded, then shouldn't that be what you get, right? Yeah. And I've seen people here without dark mode enabled, and so those people, they should be able to do that if they want, even if it's wrong. And so this is sort of where the network effects thing comes into play here, because imagine your user shows up and they've already got the data that you need. There's a lot, you don't need to do all that onboarding and have them create their first tweet and all that stuff, because they already used a bunch of apps that generated data, perhaps tweets or photos or videos. And this is kind of a potentially big deal for app developers, right? In a survey that Fluence Labs and Simple ID have recently kind of been talking about, something like 97% of dApps have less than 5,000 users. I mean, that is not a network effect that you really want to be working with. And a lot of those apps, they cite onboarding and bounce rates, so people trying and leaving right away, as a big hurdle to that, because onboarding is difficult. If you show up to a social type app and all you hear are crickets, you're not going to stick around. But if you show up and there's already, your data plus maybe some data that you've created with other apps, you've already got that, you've already jumped over that engagement hurdle. So what we're talking about is sort of like a shift from a monogamous relationship with your apps, where it's just you and your app creating data together and nobody else, what you do with your app is your own deal, to a more open relationship with applications, where essentially every app is benefiting, experiencing from the whole history of that user's interactions with other apps. So that's a good thing. And so how do we get to this sort of magical world of network impacts and user siloed sunshine? Well, like a good Web3 company, we wrote a white paper on how we think that we should do that. And we rendered it in LaTeX, so it's full of good science. And what we do in that white paper is we describe some protocols that we've developed for storing and permissioning and sharing user data using content-addressable data on top of IPFS. And then we also kind of implement as a reference implementation a bunch of tooling and libraries to help standardize that data creation and dissemination, so that we can actually realize this sort of idea of user siloed data. Because it's not enough to just make it possible to share data. You actually have to start to think about, like, okay, if I'm creating a Photos app, I need a fairly flexible structure in which to encode that photo information so that another app can take advantage of that and augment that data in some way. So we call the reference implementation of this protocol and database threads. And so the sort of long and the short on threads is that it's a protocol and a decentralized database that combines encryption, structured encoding of that data, and then content addressing to make actually moving and fetching that data possible, and it wraps it inside of a database-like API. So that essentially what you're doing is encrypting, encoding, and adding data to IPFS, but you feel like you're using MongoDB or something like that. It's open source, it's implemented in Go and TypeScript, builds on top of IPFS and libp2p. And I'm going to talk about some practical uses of it now, but obviously I spent a bunch of time talking about why you should listen to me. So that's sort of an invitation really for you to come, hit me up or any of my colleagues and ask us about that. We do have a bounty as well, so, and I think we've basically written a follow these steps, you will win the bounty blog post, so you should just do that probably. But the long and the short of it is we want to make it possible to just add IPFS. Developers should be able to add IPFS and encrypted decentralized storage to an app, to any app, without really knowing that they're using IPFS and decentralized storage and adding it to an app or any app, right? You should just be able to use these tools and use these nice principles to build something really cool. And so our team talks a lot about tool building as a sort of, we spend a lot of time thinking and working on tool building because you get these exponential benefits, right? Once you have a tool that's easy to use and that works, suddenly your creativity can really take off. You don't need to think about oh, did I pin that hash? And did I add that? And what even is the hash of this thing? None of that should matter. And is my data encrypted in a way that's going to make sense so that the user can actually extract that data within the app later on? So here's an example of a random React app where you've got views and actions, and you've got your the state of that app, your store, right? This is just it's the same as if you're using Vue or any sort of web app framework, similar with React Native, pretty classic Vue action store setup. And the idea is you shouldn't change that, right? I mean, that's how you build apps. It's pretty useful. Apparently, a lot of people have spent a lot of time developing these frameworks, and a lot of people use them, so we might as well keep using those. But maybe if we want to sync and back up and store this data in a decentralized way, you should just kind of plug in something like Threads to make that possible. And so Threads is really designed to work with existing developer workflows. And so, I have it sort of chunked onto the end there, and that's pretty darn close to what we'd like it to be and how close it is pretty now. And so we build on some awesome tools, IPFS, libp2p, and IPLD for the linked data structures. We use standard encryption tooling. We do not, develop any of our own encryption because you shouldn't do that. And all of that stuff is handled in a very best practices standard way. And it's pretty neat and it works. And here's a architectural overview diagram from the white paper because I thought maybe this is a slightly technical talk. I should put something technical in there. But honestly, the main thing to take away from this is Threads, the network protocol, handles syncing of database logs or events between peers. And then Threads, the database, handles the encryption and encoding via built-in data structures. And if you're familiar with CRDTs, then Threads supports that in order to handle collaborative editing of documents and sort of things that might produce conflicts. But you can also implement custom encoding or custom codecs. So if you've got some very simple application, you can use JSON patches, or you could use whatever it is that your use case requires. So it's very pluggable. It's very easy to customize. In both cases, you can actually host your own IPFS peers, or you can use Textile's cloud-based ones, which is really nice because then you don't even need to have an IPFS peer running. But in both cases, you can actually allocate replicators to in a trustless way, actually back up the data that your user data without actually knowing what that user data is. So as an app developer, you can run your own replicator to make sure that your users will always be able to access their data, but you don't know or have any clue what that data looks like. So if I'm creating a to-do list and I don't want you to know that I have to get milk later, that's fine. The user's data is siloed and private to them, and you're backing up to make sure that it's available. But because it's using IPFS and content addressing, and they decide that they don't want you to back up their data anymore, they can just move on to a different pinning service or provider. No problem. In fact, they could even have someone storing their data and someone providing the app to them, and those two things would work interchangeably because of content addressing. So this sounds pretty cool. And it's not just sort of pie in the sky ideas. You know, I've been saying we could and should and users can and will, but this is an actual thing that really works. We've, you know, we wrote the white paper and then we actually did the white paper thing that we said we were going to do. And the white paper is a living document, so if we modify things, we keep that pretty up to date. But these are actual tools and technologies that Textile is building, has built and is building right now. And so to give you a concrete example, we actually provide something akin to like Dropbox's public folder, which I really miss. They don't have that anymore, but used to be able to just drop things into a Dropbox public folder and it would render it like a web page if there was an index.html file. Or like an iCloud kind of a thing. So Textile calls these buckets, and you can basically drop stuff in buckets. It's replicated and added to IPFS, and people can access it. So yesterday, and that is built on threads. So that's an app, Textile, built on threads. And so yesterday I built a to-do app built on threads that uses structured, encrypted, encoded user data. And I deployed it into a bucket. So we have like a thread-based app that's rendering a thread-based app because, you know, we love these sort of recursive things. So it looks something like this, and you're like, oh my God, that's the most innovative looking React app I've ever seen. It's so different than all the other to-do app demos. And that's kind of the point, right? It's not, obviously it's not. It looks exactly like all the to-do apps out there. The only difference is I'm using MobX as the state management tool, but all of that is replicated and synced across any peers that are logged into this. And it's published to demo.textile.cafe, which is a bucket that I have, which points to some actual data on IPFS. And then I just pass in an ID with the key and to kind of cheat. But the idea is, you know, any identity that you happen to want to use, 3-box or simple ID or whatever, your users could use those identities to help create and manage their keys so that they don't have to deal with that stuff. And we spent a lot of time thinking about sort of key management and avoiding, you know, logins and specific user IDs associated with Textile. So if you have questions about that, I'm not going to dwell on it here, but I'd love to chat with you about it because it's a thing we spent a lot of time thinking about. But anyway, you know, this is a simple little app. I could have made 75 of those apps, each, you know, doing something slightly differently, rendering a basic sort of model-based structure in different interesting ways, and it would be the same underlying data that me, the user, can bring and modify and use throughout. So, you know, to kind of, if you take home one thing from this, or a few things from this talk, you might take home personal data owned by users through encryption good, and protocols for sharing and permissioning that data and services also good, and just the overall ethos of interoperability and user choice good. And the idea here is, right, if a lot of apps adopt a similar type of architecture, then a lot of apps will benefit from the other apps building. And it's this sort of like open source ethos of tides raise all boats. But to make it a little bit easier to do, you know, Textile is here. We've got tools and technologies that you can play around with to actually start implementing and building some of this stuff. So I've tried to leave myself a bunch of time for questions because I didn't get very technical. But before I open up for questions, one, thanks for showing up. Slightly more of you arrived throughout, so that was good. Also, it's a Saturday, but you still have time, so we do have a bounty. We're associated with the sort of IPFS and Protocol Labs crowd, and we have a couple of bounties. If you go to that centralized website there, you can find out more about it. Basically, if you just build a thing with Textile, we would probably give you the bounty, so you could just try that. And in fact, if you deployed something to a Textile bucket, it's also deploying it to IPFS, so you would probably kill like 2 bounty birds with 1 stone that way. So, you know, probably should do that. So if you're interested in that, I have a couple of colleagues here. You should just go and make them listen to your app idea, and then make them tell you how to build that, and then win the bounty, and you don't even need to give them any credit. Right? So there you go. Yeah, so if there's any questions, I also have a few technical slides if you want to get into details. Here, yeah.
Oh, hold on.
Oh, pause for Mike.
Thank you. So I see the point with a to-do app where users use the application to modify some data that fully belongs to them, and then they return and they can get back. But most enterprises, like the Facebooks of this world, bring to users a lot of value by collating a lot of data, summing it up, right? Processing it in chunk, or creating links and graphs. And you can't do that if everyone has their information, or at that point they need to share it. Someone will then aggregate and provide yet another level of value. So how is that possible with such a method?
Yeah, that's a great question. So, and a good summary of that is basically like you lose, or you could potentially lose a lot of data linking if everybody's data is truly siloed. And we use the term data silo because it's the opposite of sort of app siloed data. But in reality, what this is the sort of IPLD data structures that, and we talk about it a bit in the white paper of why you should use these types of data structures. They're linked data structures. So in fact, you can still create linkages between data across users. So for an example, say, you know, we use like some sort of a social networky type thing, right? So say I have my user profile and I've got a friend who has a user profile, and they posted something interesting and I happen to be following their feed. And so far, none of that requires any linkages across things. I could just view their public feed, they could view my public feed, it could still be fully siloed. But then I decide that I want to like a post in their feed. Now I have added to my user siloed data a linkage to a content address in their feed, which is a CID in IPFS world. It's a content address. And it's encrypted and coded on my side, but the CID references a unencrypted CID that I had access to because I was able to view their public feed. So now, if someone comes and views my feed and they go through and they want to check to see who, you know, what I've liked, and they also happen to be friends or happen to access that other feed, they would actually be able to traverse that like to actually access that data. So you can create cross-silo linkages in that sense. Now the real, so fine, that's like a fairly simple example of that. Now you've got millions of linkages between things. How do you handle that in a scalable way? And I think you can't handle it in a, like, not every user is going to sync the entire subgraph that they're interested in, although they can do that in theory. But another way that you do that is that you actually start to have services that are built on top of this. And we've been, you know, things like the graph and zero-knowledge replicators can actually help with some of that. So the replicators can follow linkages, but if they have the right permissions, so if the user has permission for them to do that, so that they can follow linkages between connections, but not necessarily what those actual connections are. So now suddenly they can actually index linkages across large swaths of a subgraph without necessarily knowing the specific pieces, raw data bits of that subgraph, and they can provide search and indexing features on top of that. So then you start to see that there's actually, maybe users want to pay for that type of, you know, like discoverability. You want to increase their discoverability, or they want to be able to find more users on a particular topic. And so you can start to imagine, now definitely Textile has not built this stuff yet, but you can start to imagine these types of services building on top of a protocol like this.
Okay, and I'm afraid we're out of time.
Out of time. Okay, well, thanks for showing up, and good luck out there.